In our first example, we have a 16-volt battery being applied to a circuit that has two resistors, an 8 ohm and a 4 ohm resistor that have been wired in parallel. And as always, we're going to complete a VIRP table. Tends to be the easiest way to organize this information. So the first thing we're going to do is enter everything that we know. We have two resistors, and we know their values are 8 and 4 ohms respectively. And we know that the total voltage of this circuit is 16 volts. So the first step is going to be to calculate our total resistance. We have to use that inverse equation because this is parallel. So I'm going to raise the first resistor to the -1, so 8 to the -1. I'm going to add to that 4 to the -1, and whatever that result is, I'm going to take the inverse of that, and if I do all of that carefully, I should arrive at 2.67 ohms. We see that it is a lower value than either one of those individually, since adding resistors in parallel decreases the total resistance of the circuit. Now that I have the voltage and the resistance in the total row, I can utilize Ohm's law, and plugging in the total voltage and the total resistance, I can solve for the total current, which I determined to be 6 ohms. Now, in a parallel circuit, it is the voltage that is the same everywhere, because no matter which pathway you travel through, you only go through one resistor, therefore you must spend all of your voltage at that one resistor. So I can fill out the total voltage as the same voltage being applied to every individual resistor. And now I can simply go ahead and utilize Ohm's law, V equals IR, to solve for I. And once I have V, I, and R, I can use any arrangement of the power equation, P equals IV, P equals I squared R, or P equals V squared R. It doesn't really matter. But if I do that carefully, I will find that I have my power outputs in watts, and I can use my self-check. I could certainly go through pathway number 1, and I only pass through resistor 1, which will cost me 16 ohms, so I know that I spent all my voltage. I could also travel through pathway 2 and only pass through R2. Likewise, that costs me 16 volts, and I know therefore that my odds of doing this correct are pretty high, as I spend all my voltage no matter which pathway I go through, no matter what.